Hello friends, this is Chandrakant Ghosh. Today I'll tell you about the normal distribution in this video. Normal distribution, as we all know, that is a continuous distribution. There are things like weight, height, time closely follow the normal distribution. The normal distribution curve is one of the most important statistical concepts in Lean Six Sigma. The normal distribution curve visualizes the variation in a dataset. Here in this video, I'll tell you about the characteristics of the normal distribution, and I'll give you a small example where I'll tell you how to calculate mean and standard deviation and the Z-score with the help of normal distribution. So let's see the characteristics of the normal distribution first. Normal distribution forms a unimodal bell-shaped curve where mean, median and mode are equal. Peak of the bell fall on the mean and divide the data into two symmetrical halves. That means 50% data are less than mean and 50% data are greater than mean. The curvature of normal distribution never touches x-axis, and the data distribution is like 68.2% data lies between plus minus 1 sigma, 95.4% data lies between plus minus 2 standard deviation, and 99.7% data lies between plus minus 3 standard deviation. Therefore, we can say that 34.1% data lies between mean and minus 1 sigma, and because of the symmetrical half, the same amount of data lies between mean and plus 1 sigma. Similarly, 13.6% data lies between minus 1 to minus 2 sigma, and same amount of data lies between plus 1 to plus 2 sigma. Similarly, 2.1% data lies between minus 2 sigma to minus 3 sigma, and same amount of data lies between plus 2 sigma to plus 3 sigma because of the symmetrical half. Now let's see the example and see how to calculate mean and standard deviation. The example says that 68% of employees' height in an organization are between 2.2 meter to 3 meter. How to calculate mean and standard deviation? The range of height is given. That means we can calculate mean. Therefore, mean is equal to mean is equal to 2.2 plus 3 divided by 2. We'll get the mean. Therefore, 2.6 meter is the mean. Now to calculate the standard deviation, we have to go through the example again, which says 68% of employee height is between 2.2 meter to 3 meter. And if you see the empirical rule or the above picture, you can see that 68.2% data lies between -1 sigma to +1 sigma. Here sigma is the standard deviation, which I have denoted as SD. That means standard deviation. So we can see that 68.2% data lies between -1 to +1 sigma. So if we draw the x-axis of the normal distribution here, we can see that mean +1 standard deviation, 1 SD, and here -1 SD. And mean we have already calculated, which is 2.6 meter, and the range is 3 meter, and the lower range is lower height is 2.2 meter. Now we can clearly see that the range of height is equal to the -1 standard deviation to +1 standard deviation. That means three minus 2.2 is equal to the 1 standard deviation, minus 1 standard deviation. Therefore, we will get 3 minus 2.2 will be equal to 0.8 meter, and 1 standard deviation minus 1 standard deviation will be equal to 2 standard deviation. Therefore, standard deviation will be equal to 0.8 meter divided by 2, which will be equal to 0.4 meter. Therefore, we have got that standard deviation equal to 0.4 meter. Now suppose one of the employees' height is 4.2 meter, then what will be the Z-score? Z-score measures the how many standard deviation a data point is away from the mean. That means how many standard deviation are there in between the height 4.2 meter and the mean 2.6 meter. Again, if we see in the x-axis of the normal distribution, 4.2 meter height will come somewhere here, 4.2 meter, because it is greater than 3 meter. we can clearly see that 4.2 meter will be somewhere here. That means we have to calculate how many standard deviation will come in between 4.2 meter to 2.6 meter. That means we have to calculate the distance from the mean, which will be 4.2 meter minus 2.6 meter, which is the mean. And we don't know that, since we don't know that how many standard deviation will be there in between 2.6 meter to 4.2 meter. So let's say there are n number of standard deviation are there in between 2.6 meter to 4.2 meter. Therefore, n into standard deviation. If we calculate 4.2 minus 2.6 meter, we'll get 1.6 meter, which will be equal to n into standard deviation. Therefore, n will be equal to 1.6 meter divided by the standard deviation. Which will be equal to 1.6 divided by the value of standard deviation, which is 0.4, which we have already calculated. Standard deviation value is 0.4. Therefore, 1.6 will be divided by 0.4, will get equal to 1.6 divided by 0.4. 0.4 will get the value of z-score, which is 4. Therefore, z-score value is 4. That means the height of the employee is 4 standard deviation away from the mean. So we have seen characteristics of normal distribution and how to calculate mean, standard deviation and z-score with the help of normal distribution. So this was all about normal distribution. I'll give you a few more examples related to normal distribution in my future videos. I hope you like this video. If you like this video, then don't forget to subscribe it by click on the bell icon. Add your valuable comments. Share this video to your friends and colleagues to improve and refresh their knowledge. We'll see you in my next video with another topic, that is standard normal distribution. Have a good day.